Now we are entering a new chapter, chapter 5, application of integration. The main application of integration is area. So today we discuss about area between curves. So as you know, area is very simple. Area is base length and height. Base length may be dx or dy. The height can be right function value, left function value, midpoint function value, and so on. If we choose height as right function value, this is called right sum. We choose the height as left function value. This is called left sum. And if we select the height as midpoint function value, it is called midpoint sum. So all this sum is called the Riemann sum. So we have already discussed in previous section the area we I take an example. This is x-axis, this is y-axis. This is curve y equal fx. We want area between fx and x-axis from x equal a to x equal b. How can you find this area? In previous section, this area we subdivided by from a to b and make a subrectangle like this. This is subrectangle. So this is subrectangle. The base length is dx, it's the same. This is dx, this is dx, and so on. And height may be different. Height is may be different depending on which function value is selected. If we choose right function value, this is the right sum. This is the height is this length, and we choose left function value. The height is this value. So the height is function value of fx. So this is can be fx. This is a rectangle area. The total area is sum of sub-rectangular area. It's very, very easy. What is sub-rectangular area is base length multiply the height. This is base length multiply height is sub-rectangular area. And sum is can be expressed as integration from a to b. What's the area? Area is sum of subrectangle. Subrectangle is, at this case, subrectangle is fx height multiply the base length. Rectangle of sum can be expressed as integration from where to where? From a to b. This is the area. This is area of the function between function and fx. Now how about the area? When fx is greater than dx? So the area A of a region as bounded by y equal fx and y equal gx on a and b, where fx and dx are continuous, and fx is greater than gx for all x in a and b. I will draw this curve. This curve is this is x, and this is y. 0, and we assume this is a y equal fx from a to b. Fx is greater than gx, but gx may be like this. This is y equal gx. So all x in a and b, for example, we select x is this, and function value of gx is this, function value of fx is this. So function value of fx is greater than function value of gx, always function value of gx between a and b. So we want to know this area. The same as above, the area is sum of subrectangular area. So firstly we have to find subrectangular area. Rectangular area like this area. The base length is dx. The height, height is, this is fx minus gx is height. So subrectangular area is the height minus gx is the height multiply base length. This is subrectangular area of sum. Sum is integration from A to B. This is the area S. So this is the formula of area. So the area connects the area with the definite integral. So we take an example. So we summarizing S is limit n is approaching infinite, sigma from I equal 1 to n, fx xi minus xi is the sample value. This is the Riemann sum, and we can express this by definite integration. So I will express the area by definite integration directly. So we take an example. Find the area of region bounded above y equal x squared plus 1, bounded below. This is the x and y. The y equal x squared is 1 is this. This is bounded above bounded, and y equal x is like this. Y equal x, y equal x squared plus 1. This is bounded above and bounded below, and from 0 to 1. 1 and we want to know this area. The area is the sum of subrectangular area. So we have to find subrectangular area is, this is subrectangular area. So this length is dx. This length is the function value of this curve minus function value of this curve. This is x squared plus 1 minus x. The subrectangular area is x squared plus 1 minus x. The base is dx of some integration where to where? 0 to 1. This is the area. It's very, very easy. So we can calculate this definite integration. S is integration from 0 to 1, x squared minus x plus 1. This is the height, maybe right function value or left function value. But arbitrarily x between this point and this point, the height is this. So this is the height, and this is base length. Base length is always same. We assume base length is always same. 1 dx. This is 1 over 3 x cubic minus 1 over 2 x squared plus x to the power of 2 from x equals 0 to x equals 1. 1 over 3 minus 1 over 2 plus 1. This is 5 over 6. This is the answer. Next question is find the area closed y equal x squared and y equal 2x minus x squared. And first we draw the graph x and y. Y and y equal x squared is like this. Y equal x squared. This is 0 and this is 1 and 1. Minus 1, and this is, and like this curve is, this is 2, and this curve is y equal 2x minus x squared. We want to know this area. So we enlarge this part. This part is, and x equals 0 and x equals 1. The area is the sum of subrectangular area. We make a subrectangular area. A subrectangular. So this length is dx. The height is function value of this curve minus function value of this curve. So function value of this curve is 2x minus x squared. Function value of this curve is minus x squared. So this is height and this is base length. The sub-rectangular area is 2x minus x squared minus x squared. This is the height and base length is dx of sum from 0 to 1. So this is the area. So we calculate this definite integration. And area is integration from 0 to 1. This is a 2x minus x squared minus x squared and base length is dx. So integration 0 to 1 minus 2x squared plus 2x dx. So we can calculate this. This is minus 2 over 3x cubic plus x squared from x equals 0 to x equals 1. Firstly, we input x equals 1. So minus 2 over 3, 1 cubic plus 1 square minus 3 over 2, 0 cubic plus 0 square. This is 0. And I calculate this is 1 over 3. 1 over 3 is the answer for this question. The area is 1 over 3. And next example is find area of the region bounded by curves, this curve and this curve. So it's very difficult to draw this curve and this curve. So we're using TI-84 calculator. TI-84 calculator. TI-84 calculator. Firstly we input this button, and this firstly we input this button. I think this is so this button, and you can see this display. So after pushing this button, and you input this function, so you can this function, and after input this function, and you push this button. This is the graph button, and after you pushing graph button, you can see. This graph. This graph is, we draw this graph. It's like this. This is x and y. And this is minus 1. Y equal minus 1 is asymptote, and this is this asymptote is 1. Like this curve is y equal x over square root x squared plus 1. And this curve is like this. This is a 0. This is 1. This is 1. And you want to know this area. So in order to find this area, we have to find the intersection point. This intersection point 0, and we have to find this intersection point. So this intersection point, we can find this. In order to find this intersection point, we input this math button, and you can see this display, and you can select number solve, and after select the number solver, you push the enter button, and you can see this button, and you can input function, this function and this function, and you can input initial point. It means the TI-84 find the solution near this initial point. The initial point I will input initial point 1.06, and the solution is 1.18. So approximated, this is 1.18. This is 1.18. So the area, the sum is the area is the sum of sub-rectangular. we draw a sub-rectangle. The base length is dx. The height, y height is function value of this curve minus function value of this curve. So rectangular area is, sub-rectangular area is base dx multiply, this is x over square root x squared plus 1 minus, that belongs to x to the power of 4 minus x to the power of 4 minus x to the power of 4 minus x. This is sub-rectangular area. So sum of sub-rectangular area from 0 to 1.18. Yeah, this is the area. This is the answer. This is the area. This area is integration from 0 to 1.18 x over square root x squared plus 1 dx minus integration from 0 to 1.18 x to the power of 4 minus x dx. So firstly we have to find this. This is 1 and this is 2. Integrate find 1. So we substitute u equal x squared plus 1 and we take derivative on both sides. Du equal 2x dx. The x dx is 1 over 2 du. So integration. This is du over square root u and 1 over 2. And when x equals 0, u equals 0. When x equals 0, u is 1 plus 1.18 square. 1.1L square. And this is this is 1 over 2. This is 1 over 2. Integration from u equals 0 to u equal 1 plus 1.18 square. U to the power of minus 1 over 2 du. And 1 over 2. 1 minus 1 over 2, 1. U 1 over 2. 0, 1 plus 1.18. So we can calculate this, and also we can calculate this. This is 1 over 5 x to the power of 5 minus 1 over 2 x to the power of x squared. From u equal 1 to u, no, this is x, not u. X equals 0 to x equal 1 plus 1.8. So we can calculate this, and adding this, the answer is approximated 0.785. This is the answer. The general area is, as you know, the area must be positive. The area between the curve y equal fx and y equal gx, and between x equal a and x equal b is, the area is integration from a and b absolute value fx and gx dx, because this height must be positive. So I will take an example. Find area by y equal sine x, y equal sine x, and y equal cosine x, x equals 0, x equals 2 pi. So I will draw. This is x-axis and this is y-axis. This is from 0 to pi over 2. This sine x, this is 1, and this is sine x. This is y equals sine x, and this is y equal cosine x. This is sine x, and y equal this. One is like this. Sine x. This is this is cosine x. This is x, and this is cosine x. This is pi over 4. and x equals 0, x equals pi over 2, and this area and this area. So the area is S1 plus S2. How about S1? S1 is the subrectangular area is the base length is dx, and the height is cosine x minus sine x. Sine x, the base dx, and the sum is 0 to pi over 4. S2 is integration sine x minus cosine x dx, pi over 4 to pi over 2. So you can find total area by adding S1 and S2. You can calculate this integral, and the answer is 2 square root of 2 minus 2. This is the answer. This is the area on this and this total area. The finding area is very simple. We only have to know the base length and the height of some rectangular area and the sum of this rectangular area. The second is integrating with respect to y. It means the base length is dy, not dx, dy. The area between the curve, not y equal fx, this is x equal fy and x equal dy, and between y equal c and y equal t. I will take an example. This is x and this is y. y0. We have this curve. This curve is y equals gx. Not y equals gx. This is x equals gy. And this is x equals fy. So we want to know this area. Since the x is expressed the function of y, so this is dy must be base length. So we make rectangular area. So this base length is dy, and the height is fy minus fx. So this is this intersection point C and D. The area is firstly we have to find the rectangular area is base length multiply the height. Height is gy. Correct, fy and gy minus gy dy. We have to sum this subrectangular area from C to D. This is the area when the base length is dy. So I will take an example. Find the area enclosed by y equal x minus 1, y squared is 2x plus 6. In second curve, the y is very hard to express y equal function of x. So instead of this, we express x equal function of y, and this is 1 over 2 y squared minus 6. So the area is this is. So first we have to find intersection. Intersection is this is x equal y plus 1. So y plus 1 equal 1 over 2 y squared minus 6. So 1 over 2 y squared minus y minus 7 equals 0. Y squared minus 2y minus 14 minus 14. This is 1, and this is 3. Yeah, sorry, this is 3. This is 3 and 3, and this is minus y minus 4. The y squared minus 2y minus 8 equal y minus 4, y plus 2 equals 0. The intersection point is minus 2 and 4. So, and when y between minus 2 and 4, which curve is greater than greater. So when we have to draw the graph, this is x and this is y, and this is minus 1 and 1. This straight line is x equal y plus 1. So how about this? This is x equal 1 over 2 y square minus 3. This is minus 3. This is y equals 0, x equal minus x equals 0. Y equals square root of 6. So this is minus 2. This is 4 and minus 2, and we want to know this area. And we select the base length is dy, so rectangular area is this area. The base length is dy, and height is this line minus this curve. The height is, what is height? Height is y plus 1 is greater than 1 over 2 y squared minus 3 from minus y equal, when y equal between minus 2 and 4, 1 minus 1 over 2 y squared y squared minus 3. This is the height of the subrectangle, and dy is the base length. Integration y is from minus 2 and 4. This is the area. This is the area. And this integration from minus 2 to 4, and minus 1 over 2 y squared plus y plus 4 dy. This can be minus 1 over 6 y cubic plus 1 over 2 y squared plus 4y from y equal minus 2 to y equal 4. Otherwise, this is the answer is 18. So the area is 18. So next example is find the area of region enclosed x plus 2y equals 3, y equals x, and y equals 1 over 4x. X is greater than 0. So we draw this graph. This graph is, this is x and this is y. Because y is greater than, x is greater than 0. This is y. And firstly we draw this curve. This curve is, it's x equals 0 and y equal 2 over 3, 3 over 2. This is 3 over 2 and 3. This line is x plus 2y equals 3. Y equals x is this line is y equals x, and y equals 1 over 4x is 4x is when this is the y equal 1 over 4x. So we need to find the intersection at this point and this point. Firstly, we have to find the intersection this point. This point is the intersection this curve and this curve. So y equal 1 over 4x, it means x equal y equal 1 over 4x is x plus 2 multiply 1 over 4x equals 3. 3 over 2x equals 3. And this is a 2, x equals 2. And this point is intersection between this curve and this curve. Y equals x, and this is 1. X equals 1. So we want to find this area, and this area, and this area And so firstly we have to find subrectangular area. The subrectangular, like a subrectangle, the base length is dx, and the height is different from 0 to 1, the height and this line minus this line. So this is S1 and this is S2. And S1 is integration from 0 to 1. The base length is dx, the height is x minus, this curve is 1 over 4x. And S2 is we make subrectangular area, the base is dx, the height is this line minus this line. This line is this is dx is baseline, so this curve is y minus 1 over 2x plus 3 over 2 minus 1 over 2x plus 3 over 2 minus this curve is 1 over 4x. Integration 1 over 2. So the total area is S1 plus S2. We can calculate this value and this value. The result is 3 over 4. So you can I think you can calculate this integration and this integration. So today we discuss about the application of definite integration. The main application of definite integration is finding area. So the area can be expressed by definite integration, and the area is the sum of subrectangular area. Subrectangular area is expressed by the base length and the height length. The base length can be dy over dx, and the height length is the difference between two curves. Thanks for listening to this video, and see you next time. Bye bye.